Hey everyone, Radhe Radhe. My name is Ann Parsa. I'm the Cloud Native Developer Advocate, and today we'll be learning about a really important topic, really interesting one, that is about the Ingress. It's a really important topic if you are really interested in the networking environment, in networking space of your cloud native environment or the Kubernetes environment at the moment. So, in the previous lecture, we tried to explain about the services, different type of the services that are available in your Kubernetes or the cloud environment, um, which are of three types. That is the node port, cluster IP, and the load balancers. As we discussed earlier, node ports usually acts as a, the whole services usually acts as a kind of an interface which can help you in linking or reducing the coupling between the different pods group that are available in your node or in your cluster at the moment, and acts as a connectivity interface between the user and the different pods that are available in your node at the moment. So node port usually helps in providing or registering you with a high port service. Usually it will provide you a port between 30,000 to 30,000, 32,727, I guess. I'm not accurate. So it provides a port number between 30,000 to 32,000. It helps in interconnecting you in forming up a connection between the node port number of the node and the container that is available on any of your pod at the moment. So node port will help you in building up this kind of an interface, and the cluster IP is the default IP that has been given by the Kubernetes, that has been given to your service that is being formed or settled about your cluster at the moment. So the cluster IP that is being provided at default with the Kubernetes. If you will run the command kubectl get services, then you will see the cluster IP that is already being provided by the Kubernetes, and not the node port that you will have to form, which will be provided to you at the high ports. So the node port usually helps you in building up this kind of an interface between the node and between the port number of the node and the container that is available on your pod. And the cluster IP is the default IP that is being provided to the service onto your cluster. And then comes the load balancers. So alright, so if you have any particular kind of an application that has been running onto your system at the moment, so that application will be having different port, any particular component of your application that you want to access at the moment, so that will be having a different port number, the whole URL of your component or the application instance that you're being requesting for. So instead of typing that whole particular thing, you can just pass on to access the port number, like the URL of your website, and then the port number. But I would say, instead of doing all of this, you can instead form up a kind of a web proxy server between the DNS and your service. That particular the proxy server that could be accessed by you in order to any in order to access any particular service that you've been asking for at the moment, that you want to request, that you want to that particular service that would be handling your pod in your container, for handling your container in any particular pod at the moment. So that particular DNS server could be that particular proxy server could be really helpful in order to cut short the whole mechanism of forwarding the request from you to that particular cluster. So this particular DNS, this particular thing is only possible if the DNS server has been hosted on-prem, or either on-premise, like on-premise or on the private clouds. But when it comes to the public clouds like the GCP or the AWS or the Azure and various other public cloud providers as well, then at that moment you will have to use the load balancers. So like any other particular service definition file, as we discussed before, if you are not using any cloud provider at the moment, so if you pass on this particular kind as the load balancer, then it would act normally as the load port at the moment. But if you does have any subscription, if you are buying to any particular cloud provider at the moment, whether it is about AWS or the Alibaba cloud provider or the Azure or GCP at the moment, if you forward that particular definition file to the Kubernetes will forward it to that cloud provider which you are using. And if Kubernetes gets a response, then it would be auto deployed by the Kubernetes and in the form of the load balancer. So load balancers are really helpful in forming up and handling your traffic, and split the traffic in any particular ratio, or handle them to split it and forward it to the precise or the particular service that you want to access at the moment. So it could be a really important factor of using the load balancers. But the thing is, let's say your application grows with time. Obviously, with the users base increment, your application will grow, and thus you will also try to scale up your application, and might bring some other changes, some other components, some other features that are available to your application at the moment. Let's take the example of Amazon in this particular thing. So the Amazon is helpful for the online shopping, as we all know, but it also has the Amazon Prime for the video streaming, for the video movies and the web series and TV shows streaming as well. So it will be having two different components. One is for the shopping purpose, and the other one is for the video streaming purposes. So when it comes to these different components, we will have to deploy different services. So that's why it's really important. I mean, it's really important to handle your application really carefully, because different components will be having different services, and each service will have its own load balancer. So as more services increase, load balancers will also increase, and accordingly your cloud bills will also increase. That's the factor where the FinOps and various other uh, ways other initiatives also came into the existence. If more load balancer, if more cloud bills will come, similarly your sustainability purpose won't be fulfilled. More carbon emissions would be done, and so on. I have also uploaded some other videos about the cloud sustainability part and various other things as well. You can head on to those particular videos as well if you want. So your cloud bills will increase as your load balancers increase along with the services. So the thing is, load balancers has to be configured along with the services that you have for each particular component of your application. Let's say for the video streaming purposes, you're having a different service, and a load balancer has to be configured along with it. And if you have so many components along onto your application, and configure each particular service along with the load balancers, and also implementing SSL certificates, and laying up the traffic rules as well, and configuration rules, it would be a really tedious work. So in that thing, uh, here comes the concept of Ingress. Ingress usually acts as a single accessible external URL for your application, which can be accessed by any particular user to access the service that you have been opting for, to access the particular component on your application, whether it's about the service like the video streaming purpose, or for the shopping purpose as well. In India, we usually have on the Amazon Prime, on the Amazon.in, we usually have the Mini TV as well, and the Amazon Prime as well. So we have different components now. Amazon Mini TV would be handled by some other component, and the would be acted as treated as a different component, and the Amazon Prime would be treated as a different component, because it isn't Amazon Mini TV isn't accessible by the foreign media. So it is only available on the Amazon.in. So that would be treated as a different component, different service, and different load balance. So the cloud bills will also increase accordingly. So Ingress usually acts as a single interface, a single externally accessible URL for your whole application, which can help you in configuring the load balancers along with your services, and also implementing SSL certificates, and laying down the configuration rules as well for your application at the moment. Ingress can be considered as a layer 7 load balancer that can be configured using the Kubernetes primitives. What do you mean by the Kubernetes primitives? So Kubernetes primitives are the basic components, the basic the base layer onto which the whole Kubernetes environment or the architecture has been built. As I explained in the previous lecture, all the pods, replica sets, deployments, and all of these particular things are being considered as the Kubernetes primitives. You might have also heard about the primitives in your any general language as well, any general commutative language as well, in C, C++, and various different primitives. So in the same manner, Kubernetes primitives are the pods, containers, replica sets, and deployments, and various other components, and the base components onto which the whole architecture of Kubernetes or the cloud native environment has been built. So Ingress usually helps in, it can be considered as a layer 7 load balancer, that can be configured using the Kubernetes primitives, just like any other Kubernetes objects, like the pod definition file. So to configure load balancers and implement SSLs, we use the load balancer reverse proxy solutions. We have various different reverse proxy solutions like the HAProxy, Traefik, and the Nginx. I'm wearing the t-shirt. Alright. So we usually perform this particular task in three formats. First one is the configuration, second one is the implementation, and the third one is the deployment. So the configuration usually includes the laying up of the defining of the URLs, URL routes, configuring Kubernetes and the SSL certificates, etc. All of these are considered as the configuration. Implementation, Ingress has been implemented automatically by the Kubernetes. So yeah, and then deploy any particular reverse solution, as I said just now, reverse proxy solutions that are the Nginx, HAProxy and Traefik, as I said. And then also specify the rules to configure your Ingress at the moment. So also one more thing, Ingress is usually considered to be a part of networking layer. So that's why the API version of the Ingress would be networking.kubernetes.io/viewer. So solutions that are these all particular solutions that I talked about just now. So these solutions which we deploy are being considered as the Ingress controllers, and the set of rules that has to be laid down onto your architecture layer. All of those are considered as the Ingress resources. So we'll talk about specifying these different components, whether it's about the Ingress controllers and Ingress resources. Really amazing explanation. So Ingress controllers. First of all, Ingress controllers are aren't automatically deployed by the Kubernetes onto your application layer, and these doesn't come already deployed with your Kubernetes. So you'll have to deploy them manually by the various different solutions that are available at the moment in your market, in the whole internet. You can find them. First one is the GC. GC usually acts as the Google Layer 7 load balancer. Another one is the Nginx, Istio, Contour, and HAProxy and Traefik. All of these particular solutions can be used in deploying your Ingress controllers. GC and Nginx are part of these, are already being handled by the Kubernetes project. So, and then also if you are being asked, then the Kubernetes controllers are not only responsible for splitting up the traffic between the different services, but these are also helpful in monitoring the the traffic flow between the different services. These are really helpful in monitoring the the behavior and various different the traffic that is being flowing between the different services at the moment. In order to decouple the the configuration data from your Nginx controller image, we must create a config map object as well. So these config map objects has to be defined onto your the Nginx controller file, and we are not required to I mean, it isn't mandatory to fill up the entries in these configuration maps as well, but these configuration maps in future, it could be used by you in order to explain or deploy the various different configurations that you want to adopt onto your architecture, onto your application at the moment. So these are really helpful. So that's why it has been advised to mention and deploy your configuration maps as well onto your file. We are also required to specify to pass two environment variables as well along with our Nginx controllers. That is specifying about the pod name, whichever pod we've been accessing, and the namespace name as well onto our Nginx controller definition file. We'll be seeing the whole Nginx controller file in the lab session just now, and about the various these two different environments that has been passed on to our definition file. So these were about the Ingress controllers. Ingress controller also needs some of the things that are required. In the end, I would like to specify about them all. That is the deployment of the Nginx Ingress image, and the one is the service to expose it. Alright, and the config maps to feed Nginx with all the configuration data. Config maps, as I said, doesn't need any predefined entries that has to be parsed at first. but these can be really helpful in passing the configuration entries or configuration data in the future if you want to pass. And then also service account with the right permissions to access all of these objects are also required to be passed on to the application. Right. Then comes the ingress resources. Ingress resources are the rules or the configurations that has been applied to our ingress controllers. Example, the forwarding of all the requests. If we have got certain requests and depending upon the URLs that has been came abound with those particular requests, we can spread the traffic between different components. Let's say if I have any particular request, let's say www dot what was the name of Amazon Prime slash Amazon dot in or dot com. So the Amazon dot com will be passing my request to the Amazon Prime at the moment. So it will be passing on or splitting up my request that I have passed on to the server based on the URL that I have passed with along with my request at the moment. The traffic would be routed to the application services instead of directly to the pods and backend service section defines where the traffic will move and will it route. Right. If a single backend, then if we have a single backend service at the moment, so we isn't required to pass on our request to different components. So it will be having no major such rules for the route. I mean the route rules, and just specify about the service name and then the port to the backend service. It will port to the backend service that is available in our application. If it is a need as such more routing rules at the moment, if we doesn't have that much backend that has been specified in all. So that was all about this ingress resources. There are various configuration ingress rules as well that that has to be followed in order to specify and get a better ingress planning of our architecture of the application at the moment. So we'll first start by setting up the rules to monitor the traffic and coming and route them based on the URL paths. Right. And then since in our case we only have one domain name at the moment, so that's why we only have one HTTP rule. We will only have one HTTP rule to handle traffic between the different URLs of the services or the request that has been passed to our server at the moment. And the path section is an array path section that has that is being specified in our definition file. We'll see it in a short time. So the path section usually is considered is usually being defined as an array of multiple items with one path with each URL in our definition file. Right, so that was all about the ingress and the ingress controller and various different ingress resources and rules that has to be followed in our application at the moment. Let's try to look into the definition files in our lab. Right, so here we are trying to look into the definition files that has been deployed by us of various ingress and the controller image Nginx controller as well onto our labs at the moment. So we have our, the whole Kubernetes environment at the moment, which is an available defined at the moment to experiment upon. But we have various definition files that has been, defined. That's defining the various different resources of managing our application at the moment. So here we are, kubectl get pods. All the pods are available at the moment. Sorry for that. kubectl get pods. So here we have all the pods. If you want to see, we can also specify about all the pods that are being deployed in different namespaces at the moment. We are here to discuss about the various, services ingress at the moment. So which we have discussed in the last video. Get services. You will see we have different services as well at the moment. We have the backend service that I have in the last section as well, in the last video as well, my service as well. But here now we have the Nginx Ingress. So the Nginx Ingress controller, that is being deployed in the form of the service at the moment. So we will look into it. kubectl. Let's see the different ingress as well that are running at the moment in our system. Get ingress. Yeah, whereas we watch. I took the example where we are, Wear is like the shopping app of the Amazon at the moment, and then the watch is the video streaming platform at the moment that we have deployed. So Let's look into the kubectl. First of all, let's also look into some of the deployment files that are available at the moment. Nginx Ingress Controller as the Ingress Controller image that I was talking about. So the Nginx Ingress Controller will be also containing our two environment variables. That is for the pod name and for the namespace as well. And then we also have the config maps as well that are deployed at the moment. Config maps would be helpful in handling up with the different configuration data of our application in future. So let's look into the Nginx Ingress Controller. So kubectl describe Nginx controller. Whatever. Mm, fine. Oh, I didn't mention the primitive. Yeah. So here's the name of our Nginx Ingress controller. Nginx Ingress controller namespace. I haven't mentioned any. That's why it's been set to the default. And the creation timestamp, uh, 14. That is 12 May 2025 is the timestamp. And then the labels I will mention, that's why it's been set to done. Annotations, deployment.kubernetes.io revision 1. It's a deployment file, that's why it's been having the annotations, a deployment.kubernetes.io revision 1. And selector is app, upside app in the selector as the Nginx Ingress. Then we have the replicas. Filled the replica is one. It's been set as a deployment file. That's why I also mentioned the replicas that has to be deployed onto your application, of any particular instance of the resource. And the strategy type is rolling updates. Minimum ready seconds is 0. Rolling update strategy is 25% maximum unavailable and 25% max surge. And the pod templates, it's the label. I set it to the app is equals to Nginx Ingress. Also, I mentioned about Nginx Ingress. So I mentioned the same thing. Okay. Right. So in the environment, as I was talking about, it has the pod name and the pod namespace. I said I have passed on these two environment variables in my deployment file. That's the pod name and the namespace of the pod. The conditions available, older replicas none. I didn't have any older replicas, so that's why it's been set to none. And then the new replicas, it's the name of it with the hash map or the ID or so. So it's the whole, Nginx Ingress controller that I was talking about, the definition file. Let's look into the some of the Ingress files. Yes, yeah. Right. Oh, we'll try to look into it by the YAML file, as I took about it in the last lecture. Yeah. So we were having two Ingress, I guess. So yeah. First one is the app version. Oh, all right. So in this particular in this particular defining the ingress, I took two particular examples in which the first one is the slash or the the prefix and the let's take any particular request that has been catched by our server at the moment. If it is having here at the end, like the suffix, so it will be accessing it according to the the rules that has been laid by us in this particular file. And then the other one is like specifying the whole name, whole URL. Alright, so the whole URL that we have passed with our request at the moment. So here we have in the first one, I guess it's having the whole name. I guess yeah. So the API version is require networking.kubernetes.io/v1 as I was talking. It is a part of the networking part of the Kubernetes. So that's why it's having the API version is networking.kubernetes.io/v1. Kind is in Ingress, metadata and the creation timestamp, generation, name, Ingress we have watched. Namespace is default, resource version, and UID. Then the specs rules host is vir.myonline.store. And then the HTTP paths backend service name has been like it's the different services that are being deployed or being managed at the moment in our application.
First one is via service. It's the online shopping. Let's take on that particular example on the Amazon. And the port number has been mentioned. That is 80 in both of these services. Part type is prefix, as the the it's been differentiated with the help of the prefix that has been present along with our original URL. That is whether it is via or whether it is dot watch. That's why it's prefix. So the port number is same. Service name has been changed from via to watch in this particular case, and the status load balancer is the same. So this was one example where it was depending on the prefix value of our URL. And the another one is the same networking.kubernetes.io ingress. Then the generation is one via watch ingress. Right, so in this particular thing, we will be specifying the various specs of host of my app.com with two the rules that are available at the moment, like the HTTP protocol is the HTTP paths backend service name is via service. We are having two services with the same host that is available for our application. With the same host, we are having two services being laid rules for in this particular example. Although in the previous one we were having two, right? The host was via.myonlinestore.com and the other one was the watch.onlinestore.com in the earlier example that I took. And in this one, I am having two services for the same host that have been deployed at the moment. Are deployed at the moment. So that's why it's second example. HTTP path backend service, same port number as I took in the earlier example as well, and the name is of this different services. Yeah. So the host is same in the earlier example, the host for different. Status load balancer kind is list. It is yeah, all right. So as I was talking about in the while explaining about these resources and the very different components, it's been settled up in the in the form of the arrays or the list of the arrays. So yeah, here we are. Kind is list metadata. These are the list. Right? Otherwise, it could have been in the dictionary form as well as in the metadata format. Metadata we usually have the services that are being mentioned in the form of the dictionaries, while in the specs and all, we usually mention it in the form of the list of the arrays. Because we can have multiple services that has been handled at the moment. If you want, I can also specify about one of the particular service. I can build a new service in a bit. Let's try it. Alice, oh, okay, Alice. What is it? Let's change the name of it. Nginx. Let's change the ingress integration rules. Yeah. Let's took the another example instead of taking the changing of the whole host. Instead of that, we can just specify about another. And then, yeah. All right. So ingress config rules. Um, yeah. All right. So here's the whole definition file at the moment. These are having different hosts. I don't want to play with them. Let's play with the single host because I can't have the use this much big video at the moment. Right, so it is having the same host, different services. Uh, yeah, let's specify about the path. Let's take some of the path. Uh, let's take watch 2. Uh, path type is prefix. And then the backend service. Sorry, let's show some errors about it. Yeah. So names, name, what should we name it? What should we name it? Watch to? Hey, obviously, watch to service and then the port, and then the number, same port number, that's 80. Right. So the port number has been also set as right. Right. Oh, no, yeah, right. So let's create it and then see where has been changed. Create F error. Whatever. Oh, we need to replace it. Replaced. Right, so let's take the whole name and describe it in detail because I don't want to see the whole one file as well this time. Right, so kubectl get in this time. Yeah. I named it project now. I know. Describe ingress. Oh, we can't. Yeah, wait. I don't want to see. Was it in this way? Get ingress. Oh, whatever. kubectl get ingress. Happening. Next last time. Let's pass the same context instead of that. Yeah. Here we have the same one, that is watch 2 service. Deployed the the third service as well onto our cluster at the moment. Right just now I deployed it in front of you in the whole lab session right now. So now, at the moment, we have the same host, that is myapp.com, but we have different services that has been deployed at the moment. If we have the prefix that's been adopted with the VIA service, it will be having three different services. That is the VIA, and next one would be watch service, and then the next one would be watch 2 service. It will be depending upon the prefix that has been said that has been passed by us in the request to the server at the moment. In this way, different services, different load balancers, and the ingress at the moment has been handled. But there are various, cons as well that comes along with the ingress while using ingress. We'll discuss about them all in the next lecture and discuss how gateway APIs has been, coming up as a kind of alternative in place of ingress at the moment. And we are having very different kind of gateway APIs as well in the whole market, in the whole CNC landscape at the moment. Whether it is about the K gateway API or the Kuma and various other APIs as well, and include gateway mesh as well, and various other API solutions that are coming into the whole market and the CNC landscape at the moment. So we'll try to understand about them all as well. We'll try some particular project, some other particular landscape of the project from the CNC landscape at the moment. We'll try to pick the Kuma Gateway API and the K Gateway API by the solo.io. So yeah, that was all about the Ingress. If you liked it, if you really like this particular video, if you got to know about any particular thing new, then just like it, share it, comment whatever you want, whatever views you have at the moment. And if you want any particular video to be built upon a particular topic, if you want me to research upon any particular topic from GCS and computer science at the moment, where majorly it would be I would recommend to from the security side or either from the cloud at the moment, or even the LLMs as well. So yeah, that was all about the Ingress. Thanks a lot. Radhe Radhe.